You know that saying that on average, we're only using about 10% of our brains? Well, it turns out the same applies also to how we use AI. According to recent studies, the average ChatGPT prompt is just 23 words. Explain this, fix my grammar, summarize this. Meanwhile, the latest frontier models like Claude Opus 4.5 and Gemini 3.5 Pro can handle up to 200,000 tokens per query, which is the length of an entire PhD thesis with reasoning that rivals or even exceeds domain experts. And this isn't just theoretical. In Switzerland, AI was trained to successfully control 100 million degree plasma in a fusion reactor. JP Morgan built their own AI trader trained on billions of transactions, which outperforms humans and older algorithms. Microsoft Security Copilot utilized AI to review over 65 trillion threat signals a day, spotting attack paths untraceable for humans. So, whilst most of us are still using AI to tidy up our emails, the best firms are using it to reason across incredibly complex systems, research libraries, and global threat landscapes. I'm Manny Gashi, a cybersecurity advisor and AI architect. I've assessed and built production-grade AI systems across regulated industries such as banking, energy, and critical infrastructure, where the stakes are high and the margin for error is zero. In this video, I'll show you 3 core principles that separate generic chatbots from AI that delivers real business value, ROI, and a competitive advantage for personal and corporate endeavors. And I'll prove it across live domains. So why is there such a gap between what AI can do and what most people use it for? Because for most of us, AI still lives in a browser tab. You copy and paste something in, type, explain this, get a response, and then you have to manually stitch everything together yourself. The AI has no idea about the actual environment and domain you live and work in. It doesn't know your internal obligations and processes. It has no idea about your infrastructure. It's reasoning in complete isolation. Thus, whilst big corporations and influencers continue to promote concepts like Agentic AI and autonomous copilots, very few are actually building the bridge between these models and the systems where work happens. So people walk away thinking AI is cool, but it's just a helper tool. Because the way they're using it is just a helper tool. They're trapped in a box. So the real question isn't whether AI is smart enough, it's whether we're giving it the chance to be useful. Now the big question, how do we unlock what AI can really do for us? It comes down to 3 pillars: allowing AI to see, act, and know. Think of today's AI as an incredibly smart and knowledgeable consultant. They generally know your domain, they can reason deeply, and also deliver sharp insights. But even the best consultant can only help you if they're given access to your data, the right tools, and truly understand your environment. Without that, they will always be stuck giving generic advice. In my work designing AI systems and conducting cybersecurity assessments alongside some incredible solution and security architects, I've seen the following firsthand. And these are the exact same core principles used to power the latest Microsoft, modern RAG, and Agentic frameworks. Let me walk you through what they mean and how they work in practice. First, connect the data and break the silos. As I alluded to, when AI can't see the full picture, it can only ever give you shallow outputs. The unlock involves bridging that gap, giving AI secure access to the necessary areas of your environment, such as your files, your systems, and your workflows, so that it can reason across the bigger picture. And we're already seeing this play out. Microsoft Copilot utilizes Graph API to connect and access your firm's Microsoft ecosystem. RAG systems index your documents for almost instant retrieval. And with new protocols like MCP, you can now integrate AI into almost any enterprise application. Jira, Salesforce, Confluence, you name it. Second, give it tools. AI that can see but can't act, that's like a consultant who's not allowed to touch a keyboard. When you enable AI to use tools like APIs, function calls, and control loops, the model can now decide, I need to query this system, run this calculation, call this API. For example, agentic systems can pull data from CRMs, draft responses, and execute changes, with human in the loop at key checkpoints. AI now stops advising and starts delivering. Third, ground it in your world. And this is the one that most people miss. AI doesn't know, for example, that when you say Q4, you mean your fiscal year and not your calendar year. It doesn't know what a critical finding is in the context of your company. The fix, give AI a knowledge base. Your organization's definitions, rules, and context. And this is different from giving it just data. Data is the raw information like your spreadsheets, documents, and legal apps. A knowledge base tells AI how to interpret that data. For example, in cybersecurity, we would connect our governance policies, standards, baselines, etc., which define the organization's risk management, internal requirements, remediation SLAs, and more. You can also shape AI behavior, as you probably know, through system prompts, telling it your preferred tone, format, and priorities. For example, telling it you're a compliance analyst, use formal language, and always cite article numbers. Now it starts to think like a member of your team, not a generic chatbot. Now let's see these principles through key domains, including finance, legal, and cybersecurity, and see these patterns in action with real systems and live demos. Okay, so for this live finance demonstration, I am using the Claude desktop app on my personal PC. So hence the change of scenery behind me, which is the living room. As you can see, we are running a live local Excel MCP server. So although this is obviously different to the solution design, which we just walked through, the exact same principles apply. And because this is so easy to set up locally, I will include the link to the MCP server in GitHub in the description so that you can also test out yourselves if you'd like. For the data, we'll be using 3 Excel sheets containing dummy data for a sample organization. So in this case, we have the Q4 actuals and the Q4 budget for various GL codes, and that represents the raw data. And we also have a chart of accounts, which allows AI to understand how to interpret the data in this case and grounds it in our world by understanding the specific account names, category, and approval policies, tying back to those GL codes. And let's see this in action with our first query. So in this case, we're asking the LLM, which is Opus 4.5, to use the Excel MCP server, so the tool, to effectively understand those 3 files within our environment, so directly access them and not operate as a silo, and perform the following key tasks. So compare the Q4 actuals table to the budget, so those 2 different Excel sheets together. Identify which GL codes are over budget and by how much. And for those codes, identify the department that owns them. So we're grounding the raw data responses into our world. And as you can see, another key benefit of this approach is that it allows for auditability and traceability through understanding the key steps that the LLM performs to reach its response, so that we can always trace it and understand its key operations, as opposed to the generic web chatbots, which are black boxes. Now, comparing the results, we can see that the AI has effectively synthesized the Q4 budget and actuals tables, which are in fact separate originally, but it's combined them both successfully, depicting the total budget compared to the actuals, the specific GL codes over budget, and the departments that own them. So I'll quickly show you the correctness and accuracy. So I have verified this. So for example, we can see that the digital advertising GL code is over by 15,000. And if we look at the row, digital advertising budget is 30,000 and the actual is 45,000. Thereby, the AI has effectively answered all our 3 tasks, utilizing the Excel MCP server to understand the actual data and also synthesize it across various sheets, grounding it back to our context here in the key takeaway, depicting that marketing is the biggest concern, accounting for 28,000 of a 32,000 total overrun. Now I will show you this in action through one more query, and this query is a bit more complicated than the first one. So now we're asking to create a new sheet within the Q4 Actuals Excel workbook to show a consolidated variance report, combining all 3 files with a variance column, percentage of over and under budget, and also highlighting of over budget items in red. So now we're going to explore its ability to also edit Excel sheets and not only read them effectively by creating new columns, understanding percentages, and also formatting through highlighting. So as you can see, the LLM is currently using the Excel MCP server to perform these operations. We have the paper trail of its key tool usage to understand how and why it's performing these steps. And this does take a bit of time, so about 15 seconds. So let me cut to the response once it's complete. Okay, so the LLM has completed its response, and as you can see, another key benefit is that because we're giving it access to the necessary files within our environment, it allows it to verify the final results by directly reading the new sheet, in this case, to verify that the formulas and the cell references, for example, are correct, thereby further reducing the risk of incorrect responses and hallucination. So it has created the new Variance Report sheet within the Q4 Actuals workbook with the following. Let me show you that now. Okay, so this is the new table which it has created, perfectly answering our requests. So as you can see, it has highlighted the GL codes in red that were over budget, also creating new columns depicting the total budget for the Q4 across all GL codes, the actuals, the variance dollar amount, so the over budget, the overspending, as well as the percentage of the variance. And another key benefit of this is that it has used Excel formulas and not static values for the actual totals across all columns, thereby allowing for further testing and confirmation of the results as opposed to a hard-coded and static value which generic chatbots can output. So this thereby illustrates the advantages of allowing AI to act, see and know within the finance domain, which I've shown through connecting AI to Excel MCP server, granting it the tools to effectively access our data directly, as well as interpret how to analyze it by grounding it in our context, which in this case was the chart of accounts.